Hello, this is Bob Philpot and welcome to my training video. In this video we will get familiar with the components inside the NEMA 4 training panel located in Dr. Boyd's PLC labs at Kent State. And we're also going to wire a simple start-stop relay circuit using the coil of a relay as the output. And just talk about the other components in there too. But most important, be safe and read the guidelines in Blackboard for safety. And there's a NEMA 4 panel there. It's portable, and what you have are your input switches on the left, output LEDs on the right. There's a meter, a motor on top, and there's a motor controller inside. Some other devices we'll look at. This cabinet's rated NEMA 4, which it means that basically it's indoor or outdoor use. And it rain, ice, dust, things like that keeps it out, but also protects people outside the cabinet from what's can happen inside. So it's kind of a two-way street. But if you want to look up more NEMA stuff, there's some information to find out about it. And you have to watch derating that NEMA 4 by the components you mount on it. Like here's Siemens trade show demo here of NEMA 4 switches with water flowing over them. That was kind of cool. And there's a Siemens box with, notice there's a Bluetooth antenna up on that white puck on top, and they were really heavy into the Wi-Fi and the Bluetooth, I noticed. There's the front of the panel. It's upper right hand corner is the AC power coming in, pilot light, and the other's a spare, and their switches and output LEDs. And there's the inside of our cabinet and the parts right there, and a parts list. Look them up and take the part number, and if you got to look into it, there's the part number, good list, and those numbers jive with that print right there, so you need to find them. Our AC power comes into the right there, and that's a switch for it. Our 24 volt power supply is over on the left, and we pick up our 24 volts. It comes over to the terminal strip here, and that's where we're going to wire to when we need it. And there's the power supply and its specifications if you need to look it up. This is our timer relays. They're dual pole, dual throw. There's two of them in there. And dual pole with relays mean you have two sets of contacts. So two separate commons are there, you know, and that's so two separate normally opens and two separate normally closed. And that actuating between normally open, normally closed is your dual throw. You start timing, you jump across those two pins, and the green light flickers on the front. You get to the end, you reset it by jumping across there. Gate will actuate the relay no matter what the condition. And there's 4 modes of operation, and that's the first one's your usual count up type timer, and that's what you normally use. And the flicker is kind of a clock, and then you also have, it's a one shot and basically a countdown timer, or your other modes. And like I said, no matter what you hit gate, these will actuate no matter what mode you're in either. And just remember, you know, you got the red LED showing your contacts have actuated, and the green light when it's flickering shows your timing. This is our Minirect regen motor drive at the bottom of the cabinet there, and it basically is, you know, control forward, reverse, deceleration, acceleration, tack. It does all kinds of stuff. It's pretty versatile. But there's our power coming in, and Molex connectors for our pot and our drive motor going out. Pot's on the front of the cabinet. And take note here, the two limit switches. You'll be using that to forward and reverse the motor up on top of the cabinet. And there's a couple other configurations there that you can use. This is our ice cube relay. There's 4 of them in the cabinet, and they're dual pole, dual throw. And here's the mounting block that mounts onto the DIN rail, and those are wires going into the bottom. That's the plus and minus feed for the coil there at the bottom. And this bird's eye view gives us a print that we're going to make our wire list and our ladder diagram from, using these points of reference here. This is our start, stop, seal ladder diagram that we're going to build. And what we're going to do is take the nodes from this to make a wire list so we can wire to that wire list and it'll be a lot easier. And you take node 1, which are plus voltage, and write down the contact points, and then node 2, the same thing. You write down those wire connections, and node 3 and node 4 we don't have to worry about. That's already done for us. I'll give you a little demonstration here to how to build a little terminal block, and it's the same thing you have in the panel, but there's some brochures like this floating around the lab. They're from Allen Bradley, and it tells you the specs on them. And the first one's a screw type terminal, and the other two are spring loaded like cleaver types. The bottom one will actually cut through insulation, but they all have a bus bar across there that makes one side common to the other, and that's the purpose of a terminal block, is a place to pick them up. It makes it easier to wire too. But I got a piece of 12 gauge wire here. I'll show you. They slip in there easily. And those will hold several wires. I don't know, you can put 3 or 4 in pretty easy, I think. 4 would probably be pushing it. But tighten it down, and it grabs that wire, holds it in place, makes contact, and it won't back out. It keeps it there. And when you're done, you make sure you got a good contact. You unscrew it to remove it. And simple as that. Not much to it. DIN rail is going to hold these terminal blocks in place. There's enough spring in the plastic to snap onto the DIN rail and hold them in place. They stay put pretty good. Keep them all the same orientation, going the same way. And that's a little insulator wall right there you can put onto the terminal strip to keep it insulated from the one next to it. Those are pretty nice to have when you need them. You snap it in place and pop it right on and keep populating the board. You see the gap right there between those two terminals because of the insulator. And the terminals, they slide on the rail pretty good, so you need something to hold them in place, and that's what the end caps are for. I got a screw that pulls it up to the DIN rail and holds it in place. But I also want to mention that in the upper right hand corner of the cabinet you'll see some green and yellow terminal blocks like this, and what those are ground. And what's neat about the ones we're using is we have continuity between the lugs on those grounds and the DIN rail. So there's a bond between those that's fastened right to ground. This is one of the jumper wires like you'll be using for your lab projects. They're located in the PVC tubes on the back of the chassis. They all have a unique number, and they're also tinned with solder on the end, and kind of helps since they're used so often, and they won't get frayed as bad, and you can reuse them over and over a little neater. But when you mount them on the terminal strip, you put it in, tighten it, and you feel it snug down, and at the end you give it a little tug, make sure you've got a good bite and it's not going to fall out. You just make sure they're snug and you've got a good bond there then, and it goes across the bridge of the terminal to the other lug, and so basically those two lugs on the bottom are one common point there. And there's a picture of it mounted on the DIN rail. And notice on the top there's that little ear that I told you, take a screwdriver, pops right out of there. And we'll check for continuity on across that bridge, just kind of demonstration. These are the hot and neutral, but I just go right across that block of jumper and across the bridge, and it's all one node then. And so what we're going to do is build this start-stop seal circuit, and basically use the coil of the relay will be our output. So here's our procedures. We've done some of this already with analyzing the circuit and making the ladder diagram, and basically we're going to wire to that wire list we made earlier, and that's that wire list right there where we analyzed the nodes and made a wire list from it, and we're ready to put this circuit in place and see what happens. Our NEMA rack, it's on 4 casters roll around. It's nice and portable. Each caster has a lock, You push straight down vertically, locks it, and then you take your foot and hit it horizontally, and that lever, when you hit it horizontally, that takes the brake off and releases it. And I suggest take a one of the stools and set it in front of the panel, lock those brakes in place, and get comfortable while you're working on it. Take your time and be careful. Select your wires that you're going to need. Grab a couple extra just in case, and start wiring your project. First wire we're going to do is our start button, and it's wire number 5, PB2, and that's where we tie it into the plus 24 volt. So we find wire 5, go across that bridge, pick up the terminal on the other side, hook the jumper in, and when you screw it in, you'll feel it bite into that wire, and you know you're making a good connection. And then go ahead and hook it there to the plus 24 volts, and that'll be part of node 1 for our start circuit. Next one, I'm going to use 2 wires. I'll stick 2 wires into a lug at one time, kind of cut some corners there, make it a little quicker, and you only have to do it once. I'm using wire number 1. That's part of node 2. It's push button 3, or stop button. That's these 2 wires, one of them's going to go to control relay pin 9, that's our seal contact, and the other goes to the start button, push button 2. So that's, and I put 2 wires in at one time. We'll take care of node 2 all at once. So the first one, we're going to we'll go hook it to control relay pin number 9, and that's on the bottom of the socket block for the control relays. That's the one on the right hand side, upper right. And those blocks on the control relays, you got to loosen the screw pretty good to get that wire up in the lug. They're a little more difficult to put in than they are the terminal blocks, so take a little finesse when you're putting in the control relay blocks. And give it a tug, make sure you're in there and everything's good to go. And then the second one's the other part of that, which is going to our start button. That's wire number 6 we're going to go to here. So we're jumping wire number 2 to wire number 6. A direct jumper right here. Tighten her down. Feel it bite in there. Give it a little tug while you're, and okay, we're good to go. So node 2 is completely done here now. The next wire will be our stop button, push button 3, pin 2, and wire 2. And that's where it's going to go right to control relay 1, the plus side. That'll be our actual output. This coil, energizing that coil, will be the output. So put that into the plus side terminal down underneath. That's the lower one to the left in the block. And get it in there, snug it up, make sure you're good, and that looks like a pretty good connection. And we have one more wire. That's to finish up node number 1, and what that is lug number 5 on the relay block, which is our normally open contact, and that's our seal. So we're going to put plus 25 volts on the front of that contact seal, and when you energize a coil, this is what's going to actually seal that circuit in. So put it into plus 24 volts, tighten it down, and you feel it bite. Yep, we got a good connection, I think. Give it a tug, make sure. Okay, I think this thing's ready to run. Here's a picture underneath of how they're supposed to look. Give you a good close-up of how those wires fit in, and a little description on what they are. And the top side, that's the one wire we just put in right there. And we look back at the wire list on our schematic and double check our work, and that's it. So we're ready to run. Okay, let's turn the power on. AC power's on, pilot light come on. That part's good. Start button, hey, look at that. Relay kicked on and sealed. It stayed on. You push that stop in, kills it, but it also locks in place. Got to twist it, pop it out. So we're back to starting position. There we go. Hey, it looks like it worked. Get your instructor, get an okay on this. I think we have a go. And then make sure you kill the power, and most important, unplug this thing. There we go. Okay, we got to go on the lab, so now let's clean up. We want to remove the wires that were put in during the lab. So we're removing them. Loosen the screws, and the ones that only have one wire that we put in, just go ahead and loosen the lug, and you can go ahead and leave it loose. On the one on the bottom has two wires in, our plus side of the coil, plus there's another wire that went out to the front panel to the LED as an indicator saying it's energized. So when you take out the yellow wire, make sure that that other wire going to the front panel is still there, and snug it down. And have it ready for the next guy. And let's zip through it and clean it up. Thank you for watching my video. Please send any comments, accolades, or reproach to my email. And work safely in the panel and enjoy your studies.